Hello, in today's lesson we're going to be having a look at some measures of spread. Last lesson we looked at location. We also looked at interquartile range, which is the first measure of spread, which we've all seen from GCSE. Some of you might have met these before, some of you won't have done. So this is standard deviation, which gives us an idea of how far it's acceptable to be away from the mean. Because if we collected some data, let's say people's heights, most people would be around the middle, but no one is going to be exactly average height. Well, a few people will be. But the vast majority of people will either be a little bit taller, a little bit smaller than average height. Some people will be quite a bit taller, some will be quite a bit shorter. But in general, there must be a kind of average for how far away you should be able to be from the mean. So standard deviation gives us an idea of that. Variance is used in calculations, but it's not particularly useful by itself as a measure, but it's the square of the standard deviation. So we're going to have a look at a couple of formulae, which are different ways of calculating the same thing, which is our standard deviation. So some of these are in the formula book. This top one, which is the formula for a list of data, is in the formula book, as is this version, which uses SXX, which we will meet occasionally, but doesn't come up in very many of the questions. So this version using SXX does come up from time to time. This one doesn't really come up very often, it's for individual data, so there you have to do every single value x, take away the mean and then square it and then add them up, because that's what this sigma means. This is the one that we'll use sometimes, but probably use the calculated version for this. So this is the one for tables, where you've got frequency and x values on midpoints. This is the one we use most of all, and if you've got a calculator, the calculator method, which we'll look at in a second, is very, very easy. So, onto an example. So here we get given 10 bits of data. I think there are 10, 2, 4, 6, 8, 10. There are 10. And this is the formula, straight out the formula book. Sometimes instead of sigma x over n, we have the mean, because that's what the total of x divided by the number of things is. So if I stick my whiteboard here, the first thing we're going to do is work out that there are 10 things. So n equals 10. We then need to work out sigma x, which is the sum of all of these values. So if you add them up, we get 10 for these, another 10 for these, 20, 30, and then we get 42 from here. 42. We also need to work out, I guess, the mean, because sometimes this is useful. So this is just going to be 42, the sum of all the x values over n, which comes out as 4.2. We need to work out sigma x squared, because that's in the formula just up here. So this we're going to do, I was just doing this on a calculator, by adding up and squaring all the things. So we have 3 squared plus 5 squared plus 2 squared plus 4 squared plus, I missed a squared. In a minute we'll look at doing this on a calculator. It is very easy to just get your calculator to work it all out in one go. Plus 4 squared plus 3 squared. I worked this out earlier, it should come to 208. Press equals, hope for 208, we have 208. So we have 208. So to work out the standard deviation, symbol wise we're going to use this lowercase sigma. Some people put an x on here, it's optional, but most people just put sigma. It's the square root of, and then we're going to do 208, which is our sigma x squared, divided by n, take away 42 over 10 squared. Some people, in place of this 42 over 10, use x bar, because that's what 42 over 10 is. So working this out, we have square root 208 over 10, take away 4.2 squared, because that's our 42 over 10, press equals, turn this into a number, we get 1.78. So this gives us an idea that it's acceptable to be about 1.78 away from the mean. Some people be a little bit more than that, some people be a little bit less than that. Some of them might even be, like the 4s are pretty much on the mean. But this gives us an idea about the spread in our data set. To have a look at the next one, we have the calculator method. If you want to have a quick look through this, I'll leave it on the screen for a second, but we're going to go back and have a look at our calculator method for the question we've just done. So, calculator method. Let's make sure we can reproduce this. So the first thing we're going to do is to go to stats mode, which is here, and go on one variable, because we've got one variable x and frequency. Now you can either enter this as frequency, for instance there are two 2's, so we could put this in as frequency 2, or you can just enter everything with frequency 1. If you don't have a frequency column, it's in the setup options, we looked at that last time. So with this we're going to enter all of our data, so we've got 3 equals 5 equals 4, 6, 8, 2, 4, 3, 5. So we've got 10 things, they're all entered. We're going to go on option, which is up here. The option key is just there. And then we're going to go on one variable calculations, which is option number 3. In here it gives us some information, which is quite nice. You'll notice we get given the mean and the sum of x's, which we wrote down. We also get 208, which is the sum of x squareds. And we've got our sigma here, which is 1.77. We've got the squared version as well, the variance if we wanted it. So this is entirely a replacement for the formula. So make sure you're good at doing this on a calculator, because it is much, much quicker, as you'll see in the next example. So if we had to do a table here, you would have to do an awful lot of calculations, because you need to do this times this to get sigma fx, and then so this one times this one to get sigma fx, and then this one times this one and add them all up, and then you need to do sigma fx squared, so this times this squared and then add them all up. But this we can just put in our calculator, which is the method I would suggest using. So instead of, let me get rid of this from before. Instead of doing every single little bit of this on your by hand, drawing out a table, we're going to use the calculator to do it. So going back on one variable stuff, one variable, we're going to enter this data. So we've got 35, 36, 37, 38, 39. We're going to change the frequency column to match. So we've got 3, 17, 29, 34, 26. Option, one variable calculation, and straight away we get our information. So we get the standard deviation in here, that is the one that's got sigma x is 1.09455. So we'd round this to 1.09. So the calculators are actually far better at doing this than we are. In the exam there's sometimes only 1 mark for standard deviation. If you think drawing a table and working out all these values is a good use of your time for 1 mark, it isn't, I'm afraid. So make sure you're happy doing this on your calculator. We're going to have a go at this exercise now. A quick reminder that variance is just the squared version of standard deviation. I've given you all the formula you might want here. So I'm going to pause it for a sec. Have a go at this exercise. Let us know how you get on. For the second part of this lesson, we're going to have a look at the idea of coding. So coding involves any kind of changes we might make to our data. If I asked you to go out and collect some information about maybe the date people were born in, so date of birth in years, you might actually choose to miss out, if you're doing it with all young people or children or people in your year, you might even miss out the 2000 bit and just start recording 2001 as a 1, 2002 as a 2, because this might be much easier. What we're looking at in this section is how we can go from the coded data, so the shortened version that you collected, back to the original data, and see if we can find the mean and standard deviation for our original set of data. To work out how this works, we're just going to have a look at a couple of very simple examples. So if I grab my calculator and work out some means and standard deviations for these. So one variable, I'm just going to key in. We've got one thing for each, so we've got 110, 120, 130, 140, and 150. So if I take this set of data and do option one variable calculations, I get that the mean x bar is 130 and sigma x is 14.1, and I'll keep a note of those for later. If we do some very simple coding, maybe I subtract 100 from all of my bits of data. So if we look at y and I subtract 100, I'm going to get 10, 20, 30, 40, 50. So if I go back to my table and change these to 10, 20, 30, 40, 50, 40, 50, and I rerun this calculation, option one variable calculations. If we do y is 100, sorry, x minus 100, we get y bar equals, I'm going to put y for these, equals 30, and sigma y equals, so we look back in here, we still get our 14.1. Now this is significant because the mean has actually changed according to our formula. So we took away 100 from all of our x values, and this meant that our mean went down by 100. But because we moved everything by the same amount, our standard deviation has not changed. So our standard deviation ignored the fact that we took away 100 because it's about spread of data and the spread hasn't changed. If we look at the next little example, if we code here by dividing by 10 instead. So if I go back to my table, and this time if we divide by 10, we're going to get 11, 12, 13, 14, 15. So if I put in 11, 12, 13, 14, 15, and I one variable calculation these, so if we have z, which is x over 10, we get z bar, the average for z's, is now 13. And sigma z, the standard deviation for z, is now 1.41. So when we divided by 10, that means we reduce our standard deviation by dividing by 10 as well, and our mean by dividing by 10. So when it comes to doing this with division, it's affected both our mean and our standard deviation. So this is quite nice, and then we just have to remember, if it's multiplicative, it affects both things, the mean and the standard deviation. But if it's additive or subtracting, it's not going to affect our standard deviation at all. It doesn't change the spread. All it does is it takes a set of data from here and move it over here. It's not changed the spread at all. So a little bit of summary notes if we want them. So if you have the mean, if you multiply or divide, you do exactly the same thing to the y bar. And if you add or subtract, you do exactly the same thing to the y bar. Can you see here we're adding bars to this to tell us how the mean changes. So if you knew x bar, you could work out y bar, and if you knew y bar, you could work out x bar. I'll give you a second to add this. If you want to, you can pause it. If we look at multiplicative, so if we look at standard deviation, if you multiply or divide your data, the standard deviation changes according to the formula if it's multiplicative, but if it's additive, it stays exactly the same. So if you add or subtract from your data, the standard deviation is not going to change. If you multiply or divide, it will change according to the formula. To have a look at a quick example here, we're going to look at a scientist who's measured temperature inside a nuclear reactor. So these are going to be quite big numbers, and her results are given, and then we're going to use some coding to have a look at what happens to this set of data. So our coding is given here. So these ones we'll notice have been labelled X. These ones have been labelled X. And we've got this coding here that tells us how to get Y. So the first thing to do is to run through and work out what all the Y values are. So we're going to subtract 300, and we notice they all start with 300, and then we're going to divide it by 10. So our Y values are going to be 3.2, 5.5, 0.6, 1.7, and 3.4. So we're going to calculate the mean and standard deviation. I'm going to do this using my calculator, but you could do this by hand if you prefer. So we're going to go through and we're going to change these values here. We've got 3.2, we've got 5.5, we've got 0.6, we've got 1.7, and we've got 3.4. By pressing Option, one variable calculations, we get the mean. Y bar is, so the mean of these is 2.88, and our standard deviation sigma is 1.66. So sigma Y is 1.66. What we need to do now for part C, so this is A, this is B, for part C we need to use this coding to work out the original data information. So the first thing we can do is write down that Y bar is equal to X bar minus 300 divided by 10. So we can use this to work out Y bar because we know, so X bar, because we know that Y bar we worked out in here is 2.88. So we know that 2.88 is X bar minus 300 all over 10. So multiplying up we get 28.8, and adding that over we get X bar is 328.8. We should really round this to 329 degrees because in stats we usually give things to 3 significant figures. So we can also work out the standard deviation. We can write down sigma Y equals sigma X. We're going to miss out the minus 300 and then we're going to divide it by 10. So this is our formula for working out standard deviations. And we worked out sigma Y, it's this 1.66. So we've got 1.66 is sigma X over 10. Multiplying up, we get sigma X is 16.6. So we get our mean and standard deviation for the original set of data. If you want to check these are right, you can plug the original set into your calculator. But one thing that is important to notice, in C here it says use your answer to part B to calculate. So if in part C you just calculate it using your calculator, you will not get any marks because they've specified an exact method to be used, which is your answer from part B and coding to get to your answer. Okay. This one here, they actually give us SHH. To do calculations with SHH, we need to reach for the formula book because in here it gives us, in the formula book, that our standard deviation is SXX over N square rooted. So we can use this to work out our standard deviation for H. So for H, we know that H bar is 2, and we know that sigma H is the square root of this 43.58 over n, which is 61. And this square root, I'm just going to change my square root a little bit, is everything, all of that inside the square root. So putting this in a calculator, we have, let's just go back to option 1, 43.58 divided by 61. I'm going to press equals and then I'm going to square root answer, which gives us an answer of 0.845. In here we're asked to find the standard deviation and mean for the maximum gust. Looking at our formula in here, so our formula in here tells us that to get h we do g take away 5 divided by 10. So we know that h bar is g bar minus 5 all over 10. And sigma h is sigma g over 10. And we're going to ignore the minus 5 from here because it doesn't affect standard deviation coding. So we can take this h bar and multiply it up and we get 20. And then we add over the 5, so we get g bar is 25. And the units for this are knots. With this one, all we're going to do is multiply it by 10. So sigma g is 8.45 knots. So those are our two answers. So this was literally just a case of, can we use the formula in the book, the one that's got SXX in it, or in this case SHH, and the information given in the question to work out data for H, and then can we use coding as an idea to try and get this back into mean and standard deviation for the gust, which in this case was the letter G. So now time to have a go at some from 2F. 2F, it covers questions about coding. If you do have any questions about this, feel free to let your normal teacher know. I've asked all the teachers to have a chat to you either by email or by Teams over the next couple of days to try and work out what's a good time for you to get in contact and get any help, because you're still going to need help with these questions at some point during the week.